Today's problem from mathematical expectation of two-dimensional random variable, and the problem is the random variable x and y are both standard normal and are mutually independent, right? Mutually independent. Find the expectation of maximum of mod x comma mod y. Okay, so we first write the joint PDF of x and y. Since it is given that both are standard normal and mutually independent, so we start with the joint PDF of xy is, this is given by fxy, and since it is independent, so fxx into fyy. And what is fxx and fyy? Since these are standard normal, that is normal 0 1, both are normal 0 1, so the PDF of x and y are as fxx, this is equal to 1 by root 2 pi e to the power minus x square by 2, and similarly fyy, right? So we multiply here both 1 by root 2 pi into 1 by root 2 pi, so this is 1 by 2 pi, and e to the power minus x square by 2 into e to the power minus y square by 2. So we write e to the power minus x square plus y square by 2, and minus infinity less x less infinity, minus infinity less y less infinity, right? This is the joint PDF. Now we use the definition of expectation of max mod x comma mod y. Okay, and what is the definition of expectation? Definition of expectation is given by double integration x, this is equal to minus infinity to infinity, and also y, this is equal to minus infinity to infinity, and this is max of mod x comma mod y, this is in real variable, into fxy dx dy. So fxy is 1 by 2 pi e to the power minus x square plus y square by 2 dx dy. Okay, and now we divide this integration into two parts. How to divide it? We divide it as, if we get here mod x, right, mod x, then here must be mod x greater than mod y, and this is 1 by 2 pi e to the power minus x square plus y square by 2 dx dy, and these are minus infinity to infinity and minus infinity to infinity. And the second part is double integration. This is the same. Here we get mod y 1 by 2 pi e to the power minus x square plus y square by 2 dx dy, and this is minus infinity to infinity, and this is also minus infinity to infinity, and this is mod y greater than mod x. When mod y greater than mod x, then maximum is mod y, so we get here mod y, and when mod x greater than mod y, then maximum of this is mod x, so we get, or we put here mod x. Okay, now we consider the first integration, or we may be taken as, this is I1 plus this is I2. Okay, now I1, this is given by minus infinity to infinity and also minus infinity to infinity, mod x greater than mod y, this is mod x into 1 by, we write this is 1 by 2 pi outside the integration, this is mod x e to the power minus x square plus y square by 2 dx dy. If we can find the value of the first integral, then due to symmetry we can write the value of the second integration I2 is same as I1. Okay, here mod y present, here mod x present, here the range is mod x greater than mod y, here the range is mod y greater than mod x. So due to symmetry, I1 and I2 both are same. Now if we look at that range, and this range gives that mod x greater than a, if it is mod x greater than a, then we can write the result as x greater than a and x less than minus a, right? So here also we write this is mod y and this is minus mod y if it is mod y. Okay, so we again divide this integration into two parts. The first part is given by 1 by 2 pi integration minus infinity to infinity. Here this is x greater than mod y. So the range of x, this is start from mod y and ending at infinity, because the range of x is also minus infinity to infinity. So here we get mod y to infinity, and in this case this is positive because mod y is a positive value. So we put this is x in place of mod x, because mod x is x when x is positive, right? And we get e to the power minus x square plus y square by 2. This is dx dy. And again we get this is minus infinity to infinity, and in this case the range of x is less than minus mod y. So the range from minus infinity to minus mod y. Okay, because this range gives that this is minus infinity and this is infinity. Okay, so we put this range. This is given by minus infinity to minus mod y, and in this case this x is negative, so we put here minus x, and this is e to the power minus x square plus y square by 2 dx dy. Okay, now in the second integration, only in the second integration, not in the first, only on the second integration we put minus x, this is equal to u. So we get minus dx, this is equal to du, that is dx, this is equal to minus du. And the range becomes, the range of x becomes x is minus infinity, x is minus mod y, then u is given by infinity, and mod minus mod y is given by mod y. Okay, and in this case the second integration becomes, we write only the second integration. Second integration becomes 1 by 2 pi integration minus infinity to infinity, and this integration becomes infinity to mod y, right? Infinity to mod y, and this is u, and e to the power minus u square plus y square by 2, and this dx, this is minus d, minus du into dy. And now we write this minus outside the integration, and if we change the limit of this integration by adjusting with this minus, then we get again this is plus and this is mod y and this is infinity, right? Very easy process. Now if we look at the first integration, we cannot write the first integration here because this is the same. Okay, and now if we look at the first integration, this integration and this integration are both same. except the variable u and variable x. And since we know that integration fx dx and integration fu du gives the same value at the same range, so we can write our this integration as 2 by 2 pi, because this and this are same. So we write 2 by 2 pi integration y, this is equal to minus infinity to infinity, and integration x, this is equal to mod y to infinity. This is x into e to the power minus x square plus y square by 2 dx dy. Now we write this integration as, we write here, this is, these two and these two cancel out, so this is 1 by pi into integration y, this is equal to minus infinity to infinity, and we write e to the power minus y square by 2 dy, and we first integrate with respect to x, and this is x equal to mod y to infinity, and this is given by x into e to the power minus x square by 2 dx. Right? Now we put here we put here x square by 2, this is equal to u. Okay, so we get x dx, this is equal to d, and now we change the range of integration. The range of integration becomes, this is x and this is u. If we put here x equal to mod y, then obviously u equal to y square by 2, because mod y square by 2, this is y square by 2, and if this is infinity, then this is also infinity. Okay, so we get this integration as 1 by pi integration minus infinity to infinity, and this is e to the power minus y square by 2, and this integration becomes, this is half y square to infinity, and this is e to the power minus u into d. Okay, and integrating this integration e to the power minus u du, we get, here we write 1 by pi integration minus infinity to infinity e to the power minus y square by 2, and the integration is e to the power minus u minus e to the power minus u, and the range is half y square to infinity, and this is dy. Okay, here we write dy. Now by putting the range of integration, we get e to the power minus y square by 2, and from here we get, this is given by e to the power minus infinity, this means 0, and e to the power minus y square by 2. So we get, this is e to the power minus y square by 2 dy. And adding these two exponential function, this is given by 1 by pi integration minus infinity to infinity, and this is e to the power minus y square dy. Now this is an even function, e to the power minus y square dy, this is even function. So we write this integration as this is 2 by pi into integration 0 to infinity e to the power minus y square dy. Since this is even function, we change the range of integration from minus infinity to infinity to 0 to infinity, and we multiply with 2. Okay, now we substitute, here is given by y square, this is equal to v, and this is 2y dy, this is dv, and in this case dy, this is dv by 2y, and this is dv by 2 into y means root b here, and we write this is half into v to the power minus half dv, and we write this is half into v to the power half minus 1 dv. Okay, so we substitute dy is this in this integration, and clearly the range of integration from y to v is 0 to infinity. This is also 0 to infinity. So this integration becomes 2 by pi integration 0 to infinity. This is e to the power minus v, and dy means half into v to the power half minus 1 dv. And this half, these two cancel out, and this is given by 1 by pi integration 0 to infinity e to the power minus v and v to the power half minus 1 dv. Right? And from the PDF of gamma L variate, we know that 1 by gamma L e to the power minus x into x to the power L minus 1, this is the PDF of gamma L. So the property of PDF gives the result as 0 to infinity. This is 1 by gamma L e to the power minus x into x to the power L minus 1 dx. This is 1, and this integration gives that this is gamma L. Okay, so using this integration directly here we write our result 1 by pi into this is gamma half. Now here we put the value of gamma half. What is the value of gamma half? And we know that the value of gamma half, this is root pi. So we put here root 5 by pi. This is 1 by root pi. Right? This is the value of the integration, which is I1. And we already says that the value of I1 and I2 are same. So the value of our expectation is given by, this is 2 by root pi, because 1 by root 5 and 1 by root pi, so this is 2 by root pi, and this is our final answer. Okay, very interesting problem from expectation of random variable. Thank you for watching.